Hi, and welcome to That Science Show. Today's segment, we're talking about acids and bases. And to start off with our show today, we're talking about theories and properties of acids and bases. So to start off, it's with the ionic theory. Back in the day, acids were just determined as just having a sour taste, who knew? But later it was said to be an oxide of a nonmetal combined with water. Now, this kind of was controversial because hydrochloric acid does not fit this definition. However, the ionic theory, which is still commonly used today, states that an acid is a substance that produces hydrogen ions in aqueous solution. And also, did you know that a base is a substance that can neutralize an acid? And an alkali is a base that's soluble in water. Now, with the ionic theory I already talked about, let's move on to Bronsted-Lowry acids and bases. A Bronsted-Lowry acid is a substance that donates a proton, and a Bronsted-Lowry base is a substance that accepts a proton. Consider the following reaction. HCl, gaseous state, plus H2, liquid state, yields H3O plus acid plus HCl, the HCl ion, aqueous. Under this definition, both HCl and H3O plus are acids as both can donate a proton. Similarly, both H2O and Cl are bases as both can accept a proton. Cl is said to be the conjugate base of HCl, and H2O is the conjugate base of H3O+. The conjugate base of an acid is the species remaining after the acid has lost a proton. Every base also has a conjugate acid, which is the species formed after the base has accepted a proton. Substances such as water are described as amphoprotic, which means they can act as both an acid and a base. Now, here's some typical properties of acids and bases. The typical reactions of acids are with indicators. Acid-base indicators can be used to determine whether or not a solution is acidic. Common indicators include litmus, phenolphthalein, methyl orange. And in a litmus indicator, a color of an acidic solution would be red and a color of an alkaline solution would be blue. In a phenolphthalein indicator, color in an acidic solution would be colorless, and in an alkaline solution it would be pink. And methyl orange is an indicator. The color in an acidic solution would be red, and the color of an alkaline solution would be yellow. Another type of a typical reaction of acids is a neutralization reaction with bases, with hydroxides to form a salt and a water, with metal oxides to form a salt and a water, and with ammonia to form salt. Another typical reaction with acids and bases would be with reactive metals. Of those above copper, the activity series, of course, to form salt and hydrogen. With another one would be with carbonates, soluble or insoluble, to form salt, carbon dioxide, and water. And the last typical reaction with acids would be with hydrogen carbonates to form salt, hydrogen dioxide, and water.